Hi students, I am Dr. R. Sivakumar, Assistant Professor in the Department of Chemistry, J.J. College of Arts and Science. Now we will discuss what is modern periodic law and what is a magic number, and then the long form of the periodic table, and last one is the division of periodic table into S, P, D and F log elements. So let, let us see what is a modern periodic law. Modern periodic law is nothing but the physical and chemical properties of the elements or periodic function of their atomic number. This is a very important modern periodic law. And then electronic configuration as a cause of periodicity. So the why we arising the periodicity, what is the reason is the repetition of properties of the elements after the certain intervals when the elements are arranged in the order of the increasing atomic number is known as the periodicity. The periodic repetition of properties is due to the repetition of the similar electronic configuration of elements after the certain intervals. So now we can see the another topic is a magic number. And the similar electronic configurations repeat themselves after the intervals of 2, 8, 18 or 32 in the atomic number, and accordingly the properties are also repeated after the intervals of 2, 8, 18 or 32. These numbers are called as the magic number. So this is a magic number. And then what's the long form of the periodic table? The periodic table followed today is called the long form of the periodic table and also called the Bose table. The long form of the periodic table has 18 vertical columns are called groups and the 7 horizontal rows are called the periods. So now we can see the division of periodic table into S, B, D and F log elements. The long form of the periodic table can be divided into four main groups, that is S, B, D and F log elements. The division of elements into blocks is primarily based upon the electronic configurations. So what is a S block element? The element in which the last electrons enter the subcell of the outermost energy level are called S block elements. The general electron configuration of the S block element is NS1 to 2, where N is represent the outermost cell. And what are the general characteristics of the S block elements? If the elements are belongs to the S block elements, they are soft in nature, soft metal, and have the low ionization energies and the high electropositive nature, and the very reactive and form the ionic compounds. It is a very good conducting. It's a good reducing agents. They show the oxidation state of +1 or +2. Most the S block elements which are present in the periodic table of the left hand side. So, and then the p block elements, the element in which the lost electrons enter the p subcell of their outermost energy level are called p block elements, and general electron configuration is NS2 NP1 to 6. So, what are the general characteristics of the p block elements? Are most of them are non-metal. S block elements is a metal, and p block elements are generally non-metals. Most of them are highly electronegative, and they form the ionic as well as the covalent compounds. Most of them form the acidic oxides. They show the variable oxidation state. So the classification of B block element as a metal, non-metals and metalloid as follows. If the period is equal P and number of valence electron is nothing but the N, if P plus 1 is greater than the N, then the element is metal. If the P plus 1 is less than N, the element is non-metal. P plus 1 that is equal to N, the element is metalloid. So for example, silicon, the atomic number is 14. So it depends on the period P3, and the N is the valence electron of the silicon. So it is belongs to the P plus 1 that is equal to 4. Then the silicon is a metalloid. So another one is the d block elements. What is the d block elements? The element in which the lost electrons enter the d subcell of penultimate cell, that is second to the outermost energy level, are called d block elements. The general electronic configuration is n-1d 1 to 10 and n is 1 to 2, where n is represent the outermost energy level. The general properties of the diploid elements are they are the hard in nature and high melting metals. They form a colored complex because of the vacant d orbitals. They show the variable oxidation state, and then they form the ionic as well as the compounds, covalent compounds. Most of them exhibit the paramagnetism due to the presence of unpaired electrons. Most of them possess the catalytic activities. This is a very important properties in the diploid elements. And next is F-block elements. What is the F-block elements? The element in which the lost electrons enter the subcell of anti-penultimate cell. That is, the third to the outermost cell are called F-block elements. A general electron configuration is n-2 F 0 to 14, n-1 T 0 and 1, and n-2. They consist two series of the elements placed at the bottom of the periodic table. The elements of the first series called the lanthanoids and the elements in second series called actinoids. The general properties of the F-block elements are they are high melting metals, they have the high densities, they show the variable oxidation state, and they form the colored complex. Most of them elements actinides are radioactive nature. So the F-block elements is man-made elements. It mainly depends upon the radioactive nature. Thank you.